Dear students, welcome to this class. So already in the last class we have started your chapter, the second lesson, that is matter pure around us? Is matter pure around us? Yes or no, students? Yes. So the matter is said to be pure and impure. When it is said to be pure and when it is said to be impure, I already clearly explained in the last class. Please watch that video, and again you can easily understand that pure matter means it should be made of single particle, same kind of particle. It should be made of same kind of particle. If a matter is made of different kinds of particle, that is said to be impure. Understand? So pure substances are two are there. One is elements and compounds. Elements and compounds. And impure substances are nothing but mixtures. I already explained with the examples in the last class. Understand? So, if you have confusions, please watch that video, last video, and next watch this class. Understand? Then you can clearly understand the differences between this pure matter and impure matter. Okay? So, impure matter. Already I explained about pure matter in the last class. Two are there, elements and compounds. Understand? So elements have same kind of atoms. Understand? So the particle of that element we call it as the atom. So the compounds have also same molecules. The simplest particle of an compound is called molecule. Understand? The simplest particle of an element is called atom. The simplest particle of compound is called molecule. Mind it. These are the differences between atom and molecule. The simplest particle of an element is atom. The simplest particle of compound is molecule. So elements and compounds both are said to be pure substances. Both are said to be pure matter because they are made up of same kind of particles. But mixtures, they are made of different kinds of particles. I explained with the example, that is a tea and milk. Tea and milk have a salt solution. Tea. That tea, if you want to make a tea, what you need the materials, ingredients, sugar, water, tea powder, milk. By adding all these, by mixing all these, you can prepare the tea. Yes, sir. Hence, tea is said to be mixture, and it contains more than one kind of particle, and it contains more than one kind of particle. Yes, sir. Hence, we said mixture means when two or more substances physically combine. Remember this point, very important. Take down this one in your HW. Mixture means when two or more substances physically combine, not chemically, physically combine in an uneven proportion. Understand? They have no any definite proportions. Understand? They have no any definite proportions. They have indefinite proportions. Remember. So, when two or more substances physically combine in uneven proportions, that forms what? Mixture. Remember, mixtures are said to be impure matter. It is said to be what? Impure matter. Understand, students? Let's see. This mixtures, in this class, we will go to learn about the main types of this mixture. Already I told in the last class, mixtures are two types are there: homogeneous mixture and heterogeneous mixture. Homogeneous mixture and heterogeneous mixture. See, students. So let's see. Mixture. Already I told mixture means what? When two or more substances physically combine in a uneven proportions, that forms mixture. Clear or no? So mixtures are said to be two types are there: homogeneous mixture and heterogeneous mixture. Homogeneous mixture and heterogeneous mixture. See, homogeneous mixture means the mixture which contain uniform composition. What it contain? If the mixture contain uniform composition throughout the mixture. Understand? So that kind of mixture is called homogeneous. Understand? If the mixture contain uniform composition, and if a mixture has a single phase, in other words, we can also say like this: a mixture has single phase. So that is said to be what? Homogeneous mixture. So homogeneous mixture has a single phase. It has a single phase. How, sir? How can we understand this single phase? Take a salt and water. Add the salt crystals in a water. Understand? Add the salt crystals in water and stir it well. The salts completely dissolve in water. The salt completely dissolve in water. What you get finally? Salt solution. What you get? Salt solution. Can you observe the salt particles in water? No, because salts completely dissolve in water. You can see only water. Water is a single phase. You can't see the salt particles in water. So salt solution is a homogeneous mixture. It has a single phase. It has a single phase. Understand? Take oil and water. Oil and water. Already I give this homework for you. Say, is it oil in water is a homogeneous mixture or heterogeneous mixture? Huh? Is oil completely mixed up with water? No, it cannot mix up with water. Understand? It has a separate boundary. When we mix up that oil with water, let it for few minutes that beaker undisturbed for few minutes. You can observe the separate water level and oil layer. Oil started to float on water. They cannot mix up each other. Understand? So it has a more than one phase. You can see the two phases in that solution. When you mix that water with oil, you can see the two phases. Below water phase, upon that oil phase. So that is said to be heterogeneous mixture. Understand? See, heterogeneous mixture has more than one phase. More than one phase. More than one phase. Understand? Say, students. Homogeneous mixture have uniform composition. Understand? Where is it? Homogeneous mixture have uniform composition and it has only single phase. Heterogeneous mixture have more than one phase. I give an example already. What it is? Mixture of oil and water. You just mix up that oil with water. They do not mix with each other. They are said to be immiscible. Immiscible means they do not mix up with each other. Yeah, letting it for a few minutes, you can observe separate different phases of even oil and water. Below you can see water phase, upon that oil phase. They have two separate boundaries. But in case of salt solution, you can't see that separate boundaries because salt particles get completely dissolved in water and it forms only single phase. You can't see the salt particles. Salt particles cannot be seen with your naked eye. Understand? So, the mixture which has variable composition. What is heterogeneous mixture? The mixture which has variable composition. Understand? Variable composition. That mixture is said to be heterogeneous. The mixture is said to be homogeneous if it has what? Uniform composition. If the mixture has uniform composition, then it is said to be homogeneous. If the mixture has variable composition, then it is said to be heterogeneous mixture. Understand? Let's see. The best example for homogeneous mixture is solution. One is solution. Solution is the best example for homogeneous. So hence we say solution means what? Solution is a homogeneous mixture of two or more substances. Solution is a homogeneous mixture of two or more substances. Either you can say the homogeneous mixture of solute and solvent. This mixture solution has two parts. One is solute. One is solute and the one is solvent. This solution has two parts, which are solute part and solvent part. Understand? Solute means dissolving substance. Karaguva vastu anta karitare. Solvent means the substance in which dissolve. Karagiಸಿಕೊಳ್ಳುವ ವಸ್ತು. ಇಲ್ಲಿ ಸಾಲ್ಟ್ ಸೊಲ್ಯೂಷನ್ ಇದೆ ಅಂದ್ರೆ ಇದರಲ್ಲಿ ಡಿಸಾಲ್ವಿಂಗ್ ಸಬ್ಸ್ಟೆನ್ಸ್ ಯಾವ್ದ್ರಿ? ಸಾಲ್ಟ್. ಸಾಲ್ವೆಂಟ್ ಯಾವುದು? ವಾಟರ್. Understand? Solution has mainly two parts, solute and solvent. The dissolving substance is called solute and the substance in which dissolve, that is called water. Understand? Hence we say solution means it is a homogeneous mixture of solute and solvent. Homogeneous mixture of solute and solvent is called a solution. And remember, it has a single phase. It has a single phase. Clear or not? Then come to colloids. Examples for this: heterogeneous mixture. Colloid is a heterogeneous mixture. Suspension is also heterogeneous mixture because they have different phases. They have more than one phases. They have separating boundaries. Clear or not? They have variable composition also. Hence, colloid is said to be heterogeneous mixture. Suspension is also said to be heterogeneous mixture, but solution is said to be homogeneous mixture. Clear or not, students? Very good. Let's know what is the differences between the properties of the solution, colloids and suspension. Let's see one by one. Here already I written the properties of solution, colloids and suspension. I will explain clearly. See, solution. In a solution, particles are smaller than. See, particles are small. They are very small particles. How much small is that, sir? That is less than 1 nanometer. Less than 1 nanometer. 1 nanometer is nothing but 10 raised to minus 9 meter. 10 raised to minus 9 meter means it's very small particles are there. Particles of solution are small, less than 1 nanometer. In case of colloids, particles are very small. That means particles are very smaller than the solution. Where? In colloids, particles are very small. That means 1 to 100 nanometer. That means 10 raised to minus meter to 10 raised to minus 7 meter. That means particles of this colloids are very smaller than the solution. Very smaller than the solution. Okay. In case of suspension, particles are larger. Particles are larger. That is more than 100 nanometer. More than 100 nanometer. Understand? This is the difference between the particles of solution, colloids and suspension. Let's see the second property. Solutions are transparent. Solutions are transparent. Okay. Best example already I said, salt solution. Mix that salt in a water that has only single phase and you cannot see the salt particles in that water. Water is a transparent. Solutions are transparent. Understand? Colloids. Colloids are said to be translucent. Not transparent, not opaque, but they are translucent are there. Understand? Translucent means medium transparent are there. Medium transparent are there, hence they are said to be translucent. And suspension, they are opaque. Suspension are opaque. ಅಪಾರದರ್ಶಕ ಅಂತ ಕಾಣ್ತೇವೆ ನಾವು. ಅಲ್ಲಿ ಕಾಣುವುದೇ ಇಲ್ಲ, ಫೇಸ್ ಕಾಣುವುದೇ ಇಲ್ಲ ನಿಮಗೆ. ಅರ್ಥ ಆಯ್ತಾ? Let's see. Particles cannot be separated by filtration. Okay? ಆ ನೀರಲ್ಲಿ ಉಪ್ಪು ಹಾಕಿ ಕರಗಿಸಿರ್ತೀರಿ. ಒಂದು ಫಿಲ್ಟರ್ ಪೇಪರ್ ತಗೊಳ್ಳಿ ಅಥವಾ ಒಂದು ಮನೆಯಲ್ಲಿ ಒಂದು ಥಿನ್ ಕ್ಲಾತ್ ತಗೋರಿ. ಆ ಸಾಲ್ಟ್ ಸೊಲ್ಯೂಷನ್ ಅನ್ನು ಹಾಕಿ ಫಿಲ್ಟರ್ ಮಾಡ್ರಿ. ಸಾಲ್ಟ್ ಕೆಳಗಡೆ ಬೀಳುತ್ತಾ? ಸಾಲ್ಟ್ ಸೆಪರೇಟ್ ಆಗುತ್ತಾ? ಆಗೋದಿಲ್ಲ ರೀ. ಅರ್ಥ ಆಯ್ತಾ? ಸಿ ಪಾರ್ಟಿಕಲ್ಸ್ ಕೆನಾಟ್ ಬಿ ಸೆಪರೇಟೆಡ್ ಬೈ ಫಿಲ್ಟರೇಷನ್. ಫಿಲ್ಟರ್ ಮಾಡಿದರೆ ಸಾಲ್ಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಸೆಪರೇಟ್ ಆಗೋದಿಲ್ಲ. ಯಾಕೆ? ದೇ ಆರ್ ವೆರಿ ಸ್ಮಾಲ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಆರ್ ದೇರ್. ಪಾರ್ಟಿಕಲ್ಸ್ ಕೆನಾಟ್ ಬಿ ಸೆಪರೇಟೆಡ್ ಟು ಸೇಮ್. ಇಲ್ಲಿ ಕೂಡ ಪಾರ್ಟಿಕಲ್ಸ್ ಸಿಕ್ಕಾಪಟ್ಟೆ ಸಣ್ಣದಿರ್ತವೆ, ಸೊಲ್ಯೂಷನ್ಗಿಂತ ಚಿಕ್ಕದಿರ್ತವೆ. ಅಂದ್ರೆ ಸೆಪರೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಆಗುವುದಿಲ್ಲ. ಯಾವಾಗ? ಫಿಲ್ಟರ್ ಮಾಡಿದ್ರೆ ಸೆಪರೇಟ್ ಆಗಲ್ಲ. ನೀವು ಟೀ ಮಾಡ್ತೀರಿ, ಫಿಲ್ಟರ್ ಮಾಡ್ತೀರಿ, ಟೀ ಪೌಡರ್ ಪಾರ್ಟಿಕಲ್ ಸೆಪರೇಟ್ ಆಗುತ್ತೆ. ಬಟ್ ಕೊಲಾಯ್ಡ್ಸ್ ಅಲ್ಲಿ ಪಾರ್ಟಿಕಲ್ ಚಿಕ್ಕಪಟ್ಟಿ ಸ್ಮಾಲ್ ಇರುತ್ತೆ. ಇವು ಫಿಲ್ಟ್ರೇಷನ್ ಮುಖಾಂತರ ಏನು ಮಾಡ್ಲಿಕ್ಕೆ ಆಗಲ್ಲ, ಸೆಪರೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಆಗುವುದಿಲ್ಲ. That's it. Particles can be separated by filtration. Particles can be separated by filtration. Sand ತೋರಿ, ಮರಳು ತೋರಿ, ಒಂದು ಬೇಕರಲ್ಲಿ ನೀರು ತೋರಿ, ಆ ಮರಳಲ್ಲಿ ಮಣ್ಣನ್ನು ಹಾಕ್ರಿ, ಚೆನ್ನಾಗಿ ಕಲಸಿ, ಸ್ಟರ್ ಇಟ್ ವೆಲ್ and let it for few minutes. ಹಾಗೆ ಬಿಟ್ಟುಬಿಡ್ರಿ. All soil particles are started to settle down at that beaker. ಆ ಮಣ್ಣಿನ ಕಣಗಳೆಲ್ಲ ಏನಾಗ್ತವೆ, ಸ್ಟಾರ್ಟಿಂಗ್ ನೀವು ಅದನ್ನ ಚೆನ್ನಾಗಿ ಮಿಕ್ಸ್ ಮಾಡ್ತೀರಿ, ಅದು ಮಿಕ್ಸ್ ಆದ ಥರ ಅನಿಸುತ್ತೆ. ಸುಮ್ಮನೆ ಅದನ್ನ ಡಿಸ್ಟರ್ಬ್ ಮಾಡೋದು, ಅಳಗಡಿಸ್ಲಾರ್ದು ಒಂದು ಕಡೆ ಹೇಳ್ರಿ, ಒಂದು 10 ನಿಮಿಷ ಬಿಟ್ಟು ನೋಡ್ರಿ, ಆ ಎಲ್ಲ ಸಾಯಿಲ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಏನಾಗಿರುತ್ತೆ ಆ ಬೀಕರ್ ಕೆಳಗಡೆ ಬಂದು ಸೆಟಲ್ ಆಗುತ್ತೆ. ಹೆವಿ ಆಗಿ ಪಾರ್ಟಿಕಲ್ಸ್ ಸೆಟಲ್ ಆಗುತ್ತೆ, ಕೆಳಗಡೆ ಬಂದು ಸಂಗ್ರಹ ಆಗುತ್ತೆ. ನಂತರ ಅದನ್ನ ಒಂದು ಬಟ್ಟೆ ಅಥವಾ ತೋರಿ, ಒಂದು ಫಿಲ್ಟರ್ ಪೇಪರ್ ತೋರಿ, ಫಿಲ್ಟರ್ ಮಾಡ್ರಿ. ಕೆಳಗಡೆ ನೀರು ಸಿಗುತ್ತೆ, ಫಿಲ್ಟರ್ ಏನು ಸಿಗುತ್ತೆ, ಸಾಯಿಲ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಸಿಗುತ್ತೆ. ಬಿಕಾಸ್ particles are very bigger, that is more than 100 nanometer are there. Understand? See. So particles can be separated from filtration. Filtration ಅನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಈಸಿಯಾಗಿ ನಾವು ಪಾರ್ಟಿಕಲ್ಸ್ ಅನ್ನು ಸೆಪರೇಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಚಾನ್ಸ್ ಇದೆ. ಬಟ್ ಸೊಲ್ಯೂಷನ್ ಇಲ್ಲಿ ಆಗೋದಿಲ್ಲ, ಕೊಲೈಡ್ಸ್ ಅಲ್ಲಿ ಕೂಡ ಆಗೋದಿಲ್ಲ. ಅರ್ಥ ಇದೆ? Particles are the solution and colloids are not easily separated by filtration. But only the particles of suspension can be separated by filtration because particles are very larger, they are very bigger, that is more than 100 nanometer are there. Clear or not? Okay, let's go. Solution does not scatter the beam of light. Does not scatter the beam of light. Even beam of light, a light ಅನ್ನು ಸೊಲ್ಯೂಷನ್ ಮೇಲೆ ಬಿಟ್ರೆ ಸಿ ಇಲ್ಲ ಸಾಲ್ಟ್ ಸೊಲ್ಯೂಷನ್ ಇದೆ ಬೀಕರ್ ಅಲ್ಲಿ. ಓಕೆ, ಇಲ್ಲೊಂದು ಟಾರ್ಚ್ ಅನ್ನು ಹಚ್ಚಿ ಟಾರ್ಚ್ just make allowed to pass the light rays of this torch on the salt solution beaker. ಹೌದಾ? ಈ ಟಾರ್ಚ್ ಲೈಟ್ ಅನ್ನು ಬಿಡ್ರೆ ಸೊಲ್ಯೂಷನ್ ಮೇಲೆ ಅದು ಏನು ಮಾಡಲ್ಲ, ಲೈಟ್ ಅನ್ನ ಸ್ಕ್ಯಾಟರ್ ಮಾಡಲ್ಲ. ಯಾಕೆ ಸ್ಕ್ಯಾಟರ್ ಮಾಡಲ್ಲ ಅಂತ ಕ್ವಶನ್ ಬಂದ್ರೆ ಪಾರ್ಟಿಕಲ್ಸ್ ಆರ್ ವೆರಿ ಸ್ಮಾಲರ್ ಆರ್ ದೇ. Particles are very smaller are there. Hence, the particles of this solution does not scatter the beam of light. ಬೆಳಕಿನ ಕಿರಣಗಳನ್ನು ಏನು ಮಾಡೋದಿಲ್ಲ, ಇದು ಚದುರಿಸುವುದಿಲ್ಲ. ಅರ್ಥ ಆಗುತ್ತಾ? Let's come colloids. Scatters the beam of light. ಈ colloids ಏನಾಗುತ್ತೆ, ಪಾರ್ಟಿಕಲ್ಸ್ ಗಳು ಸ್ಕ್ಯಾಟರ್ ಮಾಡ್ತವೆ. ಯಾಕೆ ಡಿಫ್ರೆಂಟ್ ಫೇಸ್ ಇರುತ್ತೆ, ಸಿಂಗಲ್ ಫೇಸ್ ಇರುವುದಿಲ್ಲ. ಇಲ್ಲಿ ಸಿಂಗಲ್ ಫೇಸ್ ಇರುತ್ತೆ, ಇಲ್ಲಿ ಡಿಫ್ರೆಂಟ್ ಫೇಸ್ ಇರುತ್ತೆ. ಹೀಗಾಗಿ ಪಾರ್ಟಿಕಲ್ಸ್ ಏನ್ ಮಾಡುತ್ತೆ, ಕಂಪ್ಲೀಟ್ ಆಗಿ ಡಿಸಾಲ್ವ್ ಆಗಿರುವುದಿಲ್ಲ. ಸೊ ಹೀಗಾಗಿ ಪಾರ್ಟಿಕಲ್ಸ್ ಏನ್ ಮಾಡುತ್ತೆ, ಲೈಟ್ ಬೀಮ್ ಆಫ್ ಲೈಟ್ ಅನ್ನ ಸ್ಕ್ಯಾಟರ್ ಮಾಡುತ್ತೆ. ಒಂದು ಬೆಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ಅಂತಂದ್ರೆ ನೀವೆಲ್ಲ ನೋಡಿರ್ತೀರಿ, ನಿಮ್ಮ ಮನೆಗಳಲ್ಲಿ ವಿಂಡೋ ಪೇನ್ ಇರುತ್ತೆ, ಕಿಟಕಿಗಳಿರ್ತಾವ. ಕಿಟಕಿಯಿಂದ ಸೂರ್ಯನ ಬೆಳಕು ಬಿದ್ದಿರುತ್ತೆ ನೋಡ್ರಿ. ಆ ಸೂರ್ಯನ ಬೆಳಕು ಬಿದ್ದಿರ್ಬೇಕಾದ್ರೆ ಕಿಟಕಿಯಲ್ಲೇ ನೋಡ್ರಿ, ಆ ಸೂರ್ಯನ ಬೆಳಕಿನಲ್ಲಿ ನಿಮಗೆ ಸಣ್ಣ 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 ಪಾರ್ಟಿಕಲ್ಸ್, ಡಸ್ಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಆ ಕಡೆ ರ್ಯಾಂಡಮ್ ಆಗಿ ಮೂವ್ ಆಗ್ತಾ ಇರ್ತವೆ. ಪಾರ್ಟಿಕಲ್ಸ್, ಮೈನ್ಯೂಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ ನೋಡಿರ್ತೀರಿ. ಎಲ್ಲಿ ನಿಮ್ಮ ಮನೆ ವಿಂಡೋ ಪೇನಲ್ಲಿ ಸನ್ಲೈಟ್ ಬಿದ್ದಿರುತ್ತೆ. ಆ ಸನ್ಲೈಟ್ ಎಲ್ಲಿ ಬಿದ್ದಿರುತ್ತೆ, ಆ ಪ್ಯಾಸೇಜ್ ಅಲ್ಲಿ ನೋಡ್ರಿ, ಆ ಲೈಟ್ ಪ್ಯಾಸೇಜ್ ಅಲ್ಲಿ ಏನ್ ನೋಡ್ತೀರಿ ನೀವು, ಮೈನ್ಯೂಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಇರ್ತವೆ, ಲೈಟ್ ಡಸ್ಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ ರ್ಯಾಂಡಮ್ ಆಗಿ ಮೂವ್ ಆಗ್ತಾ ಇರ್ತವೆ. ದಟ್ ಇಸ್ ಅ ಕೊಲಾಯ್ಡ್ ಪಾರ್ಟಿಕಲ್. That is a colloid particle because that scatters the beam of light. Understand? So then, suspension, it scatters the beam of light. Suspension can easily scatters the beam of light because it has also heterogeneous mixture. It has also more than one phase, different phases. And also main important is that what particles are very larger are there. Particles are very larger are there. That is more than 100 nanometer are there. Hence, particles of this suspension can easily scatters the beam of light. Okay, then comes to its best example for this solution is salt in water. That means salt solution. Salt solution is the best example for this solution because it has a single phase. Then best example for colloid. See, solution is called a true solution, but these are not true solutions when colloid and suspension because they have different phases. ನೀವು ಎಣ್ಣೆ ನೀರು ಮಿಕ್ಸ್ ಮಾಡಿದ್ರೆ ಎಣ್ಣೆ ಬೇರೆ ನಿಲ್ಲುತ್ತೆ, ನೀರು ಬೇರೆ ನಿಲ್ಲುತ್ತೆ. ಒಂದು ಮಣ್ಣು ತೂಡು ನೀರು ಹಾಕ್ರಿ, ನೀರಲ್ಲಿ ಮಣ್ಣು ಕೆಳಗಡೆ ಬರುತ್ತೆ, ನೀರು ಫ್ರೆಶ್ ಆಗಿ ಕಾಣುತ್ತೆ. ಅದು ಸಸ್ಪೆನ್ಷನ್ ಅಂತ ಕರಿತೀವಿ, ಮಡ್ಡಿ ಮಿಶ್ರಣ ಅಂತಾರೆ ಸಸ್ಪೆನ್ಷನ್. ಅರ್ಥ ಆಗುತ್ತಾ? ಓಕೆ, ಸೊ ಬೆಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ ಕೊಲಾಯ್ಡ್ ಈಸ್ ಮಿಲ್ಕ್ ಅಂಡ್ ದ ಬೆಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ ಸಸ್ಪೆನ್ಷನ್ ಈಸ್ ಸ್ಯಾಂಡ್ ಇನ್ ವಾಟರ್. ದಟ್ ಮೀನ್ಸ್ ಸ್ಯಾಂಡ್ ಸೊಲ್ಯೂಷನ್. ಸ್ಯಾಂಡ್ ಇನ್ ವಾಟರ್ ಮೀನ್ಸ್ ಸ್ಯಾಂಡ್ ಸೊಲ್ಯೂಷನ್. ಸಾಲ್ಟ್ ಸೊಲ್ಯೂಷನ್ ಇಸ್ ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ ಸೊಲ್ಯೂಷನ್, milk is example for colloid, and sand in water, that means sand solution is the best example for suspension. And remember students, one main thing is that solution has two parts, solute and solvent. Solute and solvent. Solute means dissolving substance, solvent means the substance in which dissolve, ಕರಗಿಸಿಕೊಳ್ಳುವ ವಸ್ತು ಅಂತ ಕರೀತಾರೆ. ಯಾವುದರಲ್ಲಿ ವಸ್ತು ಕರಗುತ್ತೆ ಅದು ಸಾಲ್ವೆಂಟ್ ಆಗಿರುತ್ತೆ. Here in salt water, here in a salt solution, solute is the salt, solvent is the water. Similarly, colloids have two parts. Colloids have two parts. Which are those? Disperse phase, and dispersing phase. Disperse phase and dispersing phase. Here also this suspension is a two parts. Which are those? Suspended particles. Suspended particles. So second the medium. See, I already explained one example, sand solution. So sand solution is the best example for suspension. This suspension also has a two parts, suspended particles and medium. Here medium, which is the medium? Medium is water. Medium is water. Suspended particles, sand particles. Suspended particles, sand particles. Understand? Here also in colloids. Here also in colloids, you have seen the two phases, disperse phase and dispersing medium. Dispersing medium. Understand? Okay. So the milk is the dispersing medium. Understand? The particles present in that milk are dispersed phase. Understand? The particles present in milk are dispersed phase and milk is said to be dispersing medium. Understand? As like a solution has a two parts, solute and solvent. Colloids have also two parts, dispersed phase and dispersing medium. Suspension also has two parts, suspended particles and medium. In a sand solution, sand particles are suspended particles and water is said to be medium. Clear or not, students? So these are the differences between the properties of solution, colloids and suspension. Clear or not, students? In the next class, we will discuss about different common examples for this colloids is there. Colloid and also Tyndall effect is there. We will discuss about that. Some examples of colloids. Different types of colloids are there in your textbook, page number 18 book. If you have books in your home, please open that 18 number, page number 89. See the chart, table number 2.1 is there. They are giving some examples of colloids. I will explain clearly that kind of colloids in the next classes and also about Tyndall effect. And next coming concept is there, separating the components of mixture. Separating the components of mixture. We will discuss both concepts in the next class. So please take down these notes in your HW and read it well. Okay, this is the homework for you. Okay, thank you students. Thank you for watching this class.